Hi, welcome to the brand new section of the course, Taking an Action in C# Functional Programming. In this section, we will cover topics such as developing functional programming in Windows Forms and creating the code behind it, creating engine code in an imperative approach, and transform the engine code from an imperative to a functional approach. So let's begin with the first video titled Developing Functional Programming in Windows Forms and Creating the Code Behind It. In this video, you'll first create a Windows Forms application and then explore how to create a form and then add the code to it. Now, we are going to develop a calculator application in a Windows Forms application. For this purpose, we have to create a new Windows Forms project and a new form with several buttons to contain the numbers 0 to 9 and additional functionality, such as this calculator. As you can see, we have 10 buttons that represent the numbers 0 to 9 and standard mathematical operators such as add, subtract, multiply, and divide. We also have some additional function buttons. They are square root, percent, and inverse. The rest includes these buttons, switch signs, decimal, clear entry, clear all, and backspace. We also have a textbook to display the number we entered and set at the top of the form. Last but not least, there is always an equal button in all calculator applications. We will give names to all these controls, as you can see here in this code. After we have all these controls, this code snippet contains only the control's name and click events, if any, that we have to set in order to ease the creation of this app since the control's name is unchanged. Additional settings, such as the control's access location, font, or alignment, don't matter since the settings won't affect the entire code. Now we will see creating the code behind the form. All controls in the form are set, and we are now ready to add some code to it. As we can see in all the event clicks in this code snippet, there are 5 functions that will be called for a specific button when pressed. Button number click, button function click, button operator click, button equals click, button clear click. Now let's look at the code snippet which implement the button number underscore click function. As we can see from this code snippet, the button number underscore click function will detect the pressed number button and then display it in the text box. For now, let's skip the calc engine, append number, and update screen functions since we are going to discuss them later. Now let's move on to the button function underscore click function, which will take an action if one of the functional buttons is pressed. The implementation of the function will be seen now. As you can see from the code snippet, button function click will take action when the button square root, button percent, button inverse, button delete, button switch sign, or button decimal buttons are pressed. For the function that is responsible when one of the operator buttons is pressed, here is the code snippet of the button operator underscore click function implementation. This button operator function will be used to run the operator for each operator, add, subtract, multiply, and divide. It then calls the prepare operation method in the calc engine class, which we will discuss later. Now to clear an entry or all entries, we have 2 buttons, and button clear all, button clear entry. These 2 buttons will call the button clear click method every time the press event is generated. The implementation of this function is like this. There are 2 methods in the calc engine class as well, which are called when these 2 clearing buttons are pressed. CalcEngine.clear for the button clear entry button and CalcEngine clear all for the button clear all button. The last button we have is the button equals button underscore click, which will call the button clear click method every time it is pressed. The implementation as follows. From this code snippet, when the button equals button is pressed, it tries to calculate the operation the user has given before calling the CalcEngine.solve method and then updating the text box. If the calculation fails, it will clear the entries. Now let's create the update screen method, which is used to display the current digit to the text screen text box. The implementation is as follows. Inside the update screen method, the format display method is called to form the display on the text. The format display method is now seen on the screen. Based on the preceding format display function implementation, the first thing that happens is that the function checks whether it is a negative number. If it does, the negative will be removed first, and then the add negative flag will be true, as shown in this code snippet. It then looks for the dot character to indicate that it is a decimal number. If the dot is found, it will store the fraction in the declare variable and the rest in the string variable, as you can see in this code snippet. Now, the function will make sure that the number is less than 1019. If it is, the code snippet will format the number. The result from the preceding format will be joined with the declared variable. If there's no fraction in the declared variable, the dot character will be added to the last position, as you can see in the code snippet. Now, if only the fraction number is available, the 0 character will be added at the first position, as seen in the code snippet. Lastly, we check whether add negative flag is true. If it is, the negative mark will be added at the first position. Great! In this video, we saw developing functional programming in Windows Forms and creating the code behind it.